20-1s. We've multiplied, we've divided rational expressions along with a whole bunch of factoring. Today we're going to add and subtract. There's a reason we did multiplying and dividing first. Through all of your grade years, you learn to add and subtract before multiply, divide. You learn to add and subtract fractions before you multiply, divide. Well, adding and subtracting rational expressions, it's a big multi-step process. Not tons of difficult things, but it is a huge multi-step process. So be attentive, and when you're told to, please do some practice. All right, very quickly, why is it such a big multi-step process? Because if we just think fraction, rational addition and subtraction, what do we have to do? Well, to add and subtract fractions, the key is you need that common denominator. This isn't new, I hope. This isn't something that's a surprise. We need a common denominator. Well, the common denominator in this case is 21. 7 and 3 can become 21. Now again, I'm going to break it into some steps, so hopefully you'll see why we do things with fractions that we're going to want to do with rational expressions. But where does this 21 come from? Well, what we can see here is if I have 6 over 7, subtract 5 over 3. To get a common denominator, we need to put in the pieces that are missing. So we have a denominator of 7, and then we have a denominator of 3. Well, really, what are we missing from this first denominator? Well, we have the 7, but not the 3, so we need to include a 3 over here. But if I include a 3, well, what's the math that sort of has to be done with that? That's the question. I want to add something, and what can I add? Well, in terms of math, if I multiply by a 3, 7 times 3 is going to give us our 21. But whatever I do to the denominator, I have to do to the numerator. Because really, I'm multiplying here. Because I multiplied by 3, because that's what I have here, I multiply by 3 over 3, which is 1. 3 over 3, which is 1, doesn't really change the value, but it gives me a denominator that has all the parts. So what do I have to do with my second fraction? Well, this 3 is missing the 7. So I want to multiply by 7. Because now my 3 times 7, there's my 21. And whatever I do to my denominator, I do to my numerator. So we multiply by 7 and then multiply by 7 to keep it equivalent. But by multiplying 7 over 7, I'm multiplying by a value of 1, and 5/3 times 1 is just 5/3. So it's the same value, but now I have a denominator of 21. So what do I get? Well, I multiplied by 3, so I multiply by 3, I get 18. I multiplied by 7, so I have the common denominator, so I multiplied by 7, and I got a 35. And 18 subtract 35 is negative 17/21. So to create these common denominators, we took what we had and we multiplied by the missing part. Multiplied by the missing part up top as well to keep it balanced. The 3, that denominator didn't have the 7, so I multiplied by the 7, but I kept it equivalent by multiplying by 7. And that's what we're going to do when we get to rational expressions. Common denominators, we need to identify what we're missing and multiply by it. Now, we'll get to more questions like that, but we're going to just take a step back first and start kind of a little slower. So if we take a look at page 9, second example, not the first example, and I just want to work with addition first. We have 2x over x plus 4 plus 8 over x plus 4. Well, to add fractions, even if there's not just numbers but expressions, we still need a common denominator. We have a common denominator. We have a denominator of x plus 4. We have a denominator of x plus 4. That's a good thing. So in terms of fractions, we just keep the common denominator. We don't do anything once we have a common denominator. Denominator stays the same. But what do we have to do? Well, we have to add or subtract the numerators. So as much as my x plus 4 is a common denominator, it stays. I still need to do the work with my numerators. So 2x plus 8 is what we have in the numerator. Add the two numerators. 2x plus 8, 2x plus 8. Because the denominator was the same. This one's pretty straightforward. We're not quite finished yet, but it's going to get more complicated. But learn to recognize denominators don't just have to be numbers. I need the same thing in each denominator, which we had. Why are we not finished? Because we always need to simplify, which was one of the first processes we did in this unit. How do we simplify? Well, if you recall, we always want to factor our numerator and denominator. Numerator can have a 2 factored out, which leaves us with x plus 4. And we still have the x plus 4 in the denominator. So I have a common factor of x plus 4 and an x plus 4. Those will cancel. So we're left with a value of 2. So our initial question of 2x over x plus 4 plus 8 over x plus 4 equals 2. Will it always equal 2? Not necessarily, because again, we always need to identify those NPVs. What are the values throughout this question that would create an undoable question? Question we couldn't do? That's if our denominator equals 0. What would make a denominator of 0? If x equaled negative 4. So our NPVs are when x equals negative 4. Make sure you identify. So our answer is 2 as long as x didn't equal negative 4 during the question. There you go. Let's go through a couple other ones fairly quickly now. Let's go back to the first one. First one, you have to be careful because of the subtraction. So again, first thing, require a common denominator. Denominator of b, denominator of b. Fantastic. We have a common denominator. We don't have to worry about it. What do we do now? We add or subtract the numerators. Well, here we have 2a subtract a minus 1. But that's going to be a problem. This won't get us the correct answer because we want to subtract all of a minus 1, not just some of it. So whenever it's subtraction, we need to make sure the second term, polynomial numerator, whatever you want to call it, goes in brackets so that this negative will distribute. So we're left with 2a minus a plus 1 over b. Because we're subtracting, the negative distributes. Can we simplify? Make sure you simplify. Our first simplification, 2a subtract a, or a 1a if it helps, leaves us with a. We still have plus 1 over b. Is there anything we can do with a plus 1 over b? There isn't. No simplifying further. There's our answer. 2a over b subtract a minus 1 over b is the same as a plus 1 over b as long as our NPVs, b is the only variable we need to work with because it's the only variable in the denominator, and b can't equal 0. So the non-permissible value is b equal to 0. It's not allowed. Next one. Stop the video. Give it a try. See what you come up with, and then we'll talk. All right. Now we have 3 terms. Not a big difference. 3 terms, 3 fractions. We still need that common denominator for the 3 terms. What's great? X minus 2, x minus 2, x minus 2. So that works nice. This will equal a denominator of x minus 2. Because our denominator is already there, we don't have to do anything to the numerators. So what are we left with? We're left with the x squared plus a 3x subtract a 10. I don't need brackets in this case because I'm just subtracting a single monomial, one term. It doesn't affect anything. X squared plus 3x minus 10 over x minus 2. Is that our final answer? We had a common denominator. We added and subtracted numerators. But can we simplify? Remember that students, don't think that 2 and 10 can cancel. This is an x minus 2. I can't cancel part of it. I have to cancel the whole thing, if anything. Simplify. Factor your numerator and denominator for simplifying and see if they have common factors. X squared plus 3x minus 10, simple trinomial. What multiplies to negative 10 but adds to 3? Positive 5, negative 2. So we end up with x plus 5, x minus 2, simple trinomial over x minus 2. Now we have our common factors of x minus 2. So the final value for this addition subtraction of rationals is just x plus 5. But it's only going to be x plus 5 as long as we don't have what NPVs. The only thing we end up with in our denominator ever is x minus 2, and the only time that'll be bad is if we get a denominator of 0, and that'll happen if x equals 2. So x plus 5 is our answer as long as we don't have x equal to 2. Last one before we get complicated. Give this one a try, and then we'll talk. So here, what's nice? Well, one more time before we get a little uglier. 4m minus 3, 4m minus 3, common denominator. Fantastic, is 4m minus 3. So what do I have to do? I add and subtract my numerators. I have 10m minus 1, and I want to subtract 8 minus 2m. But because I'm subtracting multi-terms, I need to make sure that's in brackets. So I end up with, if I distribute, 10m minus 1 minus 8 plus 2m. And that's over my common denominator of 4m minus 3. What can I do to simplify here? Well, 10m and 2m is 12m. Negative 1, negative 8 is a negative 9. And that's over 4m minus 3. Have we simplified completely? We haven't, because remember, simplifying means you factor each numerator and denominator and cancel if you can. Sometimes that might be my final answer, but in this case, I'm really hoping you recognize that your top can be factored, your numerator, because you can factor out a GCF term of 3, which would leave you with 4m minus 3 over 4m minus 3. So 4m minus 3's cancel out, and that initial subtraction of rationals equals 3. As long as we don't have m values of what? Well, our denominator, the only denominator we have is 4m minus 3. So if 4m minus 3 equals 0, that's a bad thing, and that will happen if m is 3/4. So we will get an answer of 3 as long as m does not equal 3/4. So that's what we want to look at doing, adding and subtracting rationals. Common denominator, add or subtract numerators, simplify. Here's where we're going to start to run into some difficulty. Let's turn to page 10. Start off easy and then do a couple that are a little bit more involved. Common denominator. So 2x over x minus y, subtract 4 over x squared. In this case, we have, I'm just going to write it out the first time in parts so you can see how we come up with the common denominator. Our denominator has to have all the parts the same. So this denominator has an x and a y. This denominator has an x and an x. We need both denominators to have the exact same stuff. Well, what's this first denominator missing? Well, it has an x and a y. It has the x, but it doesn't have the second x. So we need to, in this case, multiply by an extra x, because that will then give me 2 x's in each denominator. But if I'm going to multiply an x in my denominator, I need to multiply the x in the numerator as well. So I have to include a times x to get a common denominator that will be the same of x squared y. The second rational, we have the x and the x. Well, 1x was the same. That had an extra x, but this doesn't have the y. So we need to multiply by a y to make sure it has the y that that denominator has. If I'm going to multiply by y to put it into my common denominator, I need to multiply by y to keep it equivalent. And so now I have two x's and a y, two x's and a y, so my common denominator is x squared y. What am I now left with up top? Because this first step, it requires a common denominator, the expression as opposed to just a numeric value. We don't just have a 4 or a 12. But any added part to the denominator has to multiply by the numerator, which is what we did. Had to put in an x, we times an x, we times an x. Had to put in a y, we times the y, we times the y. But now we need to make sure we do this work up here. What's 2x times x? That leaves us with 2x squared. Subtract 4 times y is a 4y. So our common denominator resulted in a numerator of 2x squared minus 4y. Are we finished? I'm just going to bring this down here so I have space to work with it. Question is, are we completed? Well, what do we have to do in order to simplify? First thing is we need to factor if possible. What can we factor? We can factor out a 2, which leaves us with x squared minus 2y over x squared y. Are there common factors here? There are not, so there's our simplified form. And in that case, what we need to do then is identify the NPVs. And our NPVs in this case, well, is this x squared y. What's going to create a denominator of 0? Denominator of 0 will happen if x equals 0, because 0 squared is 0. And y, if it was 0, 0 times anything is 0. So there's what we can't have. And there's what we want to do. Now the next two are going to be a little bit more involved because they have some factoring work, which we haven't seen yet. So here's our new step 1. Factor the denominators. Technically, we don't have to factor the numerators until we go to simplify. I'm just going to factor the denominators because that's all we need to do to start with. So here we go. We have y squared minus 20 over, and then we have a y minus 2 over. Y squared minus 4. We can factor that because it's a difference of squares. Y minus 2, y plus 2. And we have a y plus 2 over here. So we've factored, and now we have expressions, but we need all of the exact same expressions in our denominator. We have a y minus 2 and a y plus 2, and we have a y plus 2. This rational here isn't missing any factors that the other rational has. So right now, y minus 2 and y plus 2 is a good start for the denominator. When I look at the second rational, I have a y plus 2. Well, that's good because that's part of it, but what's it missing? It's missing the y minus 2. So I'm going to have to multiply by y minus 2 here, and I have to multiply by y minus 2 in my numerator. That gives me the correct denominator, and up here it keeps it balanced. Well, this is where you start to see the size and the number of steps that these questions can have. Because here's what we have remaining now in our numerator. Our denominator, we're happy with y minus 2, y plus 2. We didn't have to do anything here. Y squared minus 20, we were okay with that. But now we had to multiply by y minus 2 over here, so I need to do the simplification. Y minus 2 times y minus 2, show your FOIL steps, but it'll work out to be y squared minus 4y plus 4. So we get big polynomials, lots of steps in these questions. At that point, well, we need to simplify our numerator. We've done the multiplying, but now we need to combine our like terms. Y squared and y squared, 2y squared. Negative 4y, and negative 20 plus 4 is a negative 16. And all of that is over y minus 2 times y plus 2. So there's the answer that we get from all of our steps, but are we finished? That's the question. We're not, because we need to simplify. This can be an entire question all by itself. So here we go. I don't have to factor the bottom because it's in its factored form. But after I combined all my terms, now I have a polynomial that could be factored. I'm going to factor it over here on the side. First thing I can do is factor out a 2. Leaves me with y squared minus 2y minus 8. Well, I still have a trinomial here. Simple trinomial. What multiplies to negative 8 but adds to negative 2? Well, it's going to be negative 4, positive 2. Negative 4, positive 2. Because negative 4 times 2 is negative 8. Negative 4 plus 2 is negative 2. So there's the factored form for what I had remaining in my numerator. And now that I have the factored form, now I can finish the simplifying. I see that I have a y plus 2 and a y plus 2 that can cancel out, and nothing else will cancel out. So my final answer is 2 times y minus 4 over y minus 2. And we can leave it in that form. We don't need to expand it. Simplify, but like we did back then, is we can leave in the factored form. Doesn't have to be expanded form there. We need to expand here so that we can combine everything to get our numerator. But our final answer, that's okay. And now we need to go back very quickly and check our NPVs. Y minus 2, y plus 2, that's the only thing we had in our denominators. So our NPVs, if y minus 2 equals 0, that's because y equals 2. If y plus 2 equals 0, that's because y equaled negative 2. So here's our answer as long as y doesn't equal 2 or negative 2. Lots of steps. Here's the next one. This is on page 11. Give it a try, see what you come up with, and then we'll talk. All right, here we go. First things first, factor the denominators. Simple trinomial here. So we're going to have x minus 1 over x plus 3 times x minus 2, because negative 3, or 3 and negative 2 is negative 6. 3 plus negative 2 is 1. Subtract, we have the x minus 2 over another simple trinomial. What multiplies to 3 but adds to 4? 3 and 1. X plus 3 times x plus 1. So we factored things. Now we need to make sure we know what our common denominator has to be. Well, we see that this has an x plus 3 as part of the denominator. This has an x minus 2 as part of the denominator. This has an x plus 3, which we already have. This rational has an x plus 1, which we don't have. So there's the parts that have to make up the common denominator. What's missing from each? Well, we can see here that we don't have this x plus 1. So we're going to have to multiply by x plus 1 here. So I'll have to multiply my top by x plus 1. Here, we're missing the x minus 2. So I'm going to have to go x minus 2 to put it to the common denominator. I'm going to have to go x minus 2 up top to maintain equivalence. So I'm going to have to move down just for spacing. Here we go. Our common denominator is x plus 3, x minus 2, and x plus 1. Because that's all the parts from each of the two rationals. We had to multiply our x minus 1 by x plus 1. FOIL, x squared minus 1. We then had to put this x minus 2 in, which means I need to multiply that numerator by x minus 2 as well. FOIL again. We're subtracting. So I need to subtract and put it in brackets because I need to make sure I subtract all of the polynomial. Do the FOIL steps, x squared minus 4x plus 4. Distribute the negative. Now I need to simplify my numerator. X squared minus 1 minus x squared plus 4x minus 4 because the negative got distributed. And that's over x plus 3 times x plus 2 times x plus 1. Simplify the numerator now. X squared and negative x squared cancel. So we're left with 4x minus 5. And that 4x minus 5 goes over x plus 3 times x plus 2 times x plus 1. Here, 4x minus 5 can't be factored. This binomial can't cancel with any of the binomial factors. So there's our solution. 4x minus 5 over x plus 3, x plus 2, x plus 1, as long as this is an x minus 2. I messed up, I'm sorry. It's an x minus 2. So our NPVs become x. NPVs means x cannot equal negative 3 because it would make a 0, positive 2 because it would make a 0, negative 1 because it would make a 0. So there's our solution as long as we don't use those values for x. Sorry, that's a negative 2 on the bottom. I had it there though. So lots of little steps to get a common denominator and maintain equivalence. Lots of little bits of work. Assignment, textbook, page 1, 2, 3, 5, and 6. Start into it. We're going to actually do one more lesson with this and take a look at a special situation that's a little bit more complicated, but this is a great start. Do the practice. Get the basics down before we get to the ugly questions. Have fun with it.